to page 3. Just a few multiple choice questions here, so this should go fairly quickly. Let's see, which of the following sets of numbers can be the sides of a right triangle? We know Pythagoras has to hold true. A squared plus b squared has to equal c squared. If that's true, we have a right triangle. If it's not true, not a right triangle. So let's just try. The 4, 8, 9 is 4 squared plus 8 squared equal to 9 squared, question mark. 16 plus 64, is that equal to 81? No, that's 80. That's not equal to 81, so that's no good. 9, 16, 25. So 9 squared plus 16 squared, is that equal to 25 squared? So 81 plus 284, 16 by 16. 16 by 16, 4 carries 6, 12, 16, 284. 284. Is that the same as 625? That's no. So that's not true either. How about 20, 21, and 29? Let's try that guy. Okay, so 20 squared plus 21 squared, is that equal to 29 squared? So we have 400 plus 441. Is that the same as 29 squared? Well, and obviously you have a calculator on here, but I would hope 29 times 29, 81. So 9, 7, and then 8, carry 1, 5. So 1 and 5 and 6, 7. I can't multiply here. 18. Okay, let's try this again. It's been a long day. Yes, you have your calculator. 29 times 29. Why, carry 8. 18 and 8 is 26. 8 and 1, 5. There we go. 4, 8, 41, 8, 41. Yep, got it. Okay, so this is the correct answer. We wouldn't have to try the last one, but if you did, you would find that one does not work as well. Okay, so yes, for right triangles, make sure the Pythagorean theorem works, and then you're good. Lines that are not coplanar, by definition, those are skew. That's a quick one. A linear pair of angles consists of this many rays. I would probably go to the glossary and look at what a linear pair is. You see it has 2 opposite rays and then a third ray meeting at that vertex. So there's three rays in a linear pair. 2 triangles that have equal bases and equal altitudes. Well, you know the area of a triangle is 1/2 base times height, where height is the altitude, so they have equal areas. Which of the following polygons are similar? I thought we saw that in an earlier question. Isosceles triangles, no. These certainly don't have the same shape, so that's out. All squares, yes, that is true. Any square that I draw, no matter what size, they all have the same shape, so that's the answer B. Rectangles, no. If you tried to draw in a short rectangle and then a longer rectangle, they do not have the same shape. I guess suppose they're both rectangular, but to be the same shape, the sides would have to be in proportion, so that's no good. This one is B. Okay, 65 was just a typo. I'm sorry to mislead you on that. There is no such thing as the remote angle of a triangle. So that's just sort of a bad question. It should have read an exterior angle. An exterior angle, T-E-R-I-O-R, of a triangle is. So yes, you're supposed to know what an exterior angle is. Let's draw a picture. So here's a triangle. An exterior angle is formed by extending one of the sides, and it's this angle out here. This is called an exterior angle on the outside of the triangle. Every triangle actually has 6 exterior angles. So if you imagine your triangle, that's an exterior, so is that and that, and so is that and that. Okay, so if that were the question, now let's look at the answer. An exterior angle is equal to the sum of the 2 remote interiors. So this red one on the outside here is equal to these 2 added up. And so take this one and this one. They don't have to be the same, but if we call these A, B, C, and this is point D, we can say angle A plus angle B is equal to angle ACD. That's one of the statements about exterior angles. Okay, 66, two parallel lines cut by a transversal. Get a little sketch going. Parallel line, transversal. How many pairs, bold, of corresponding angles? This one corresponds with that. That would be one pair. This one corresponds with that. That would be one pair. This one here would correspond with that. That's one pair. And the last pair is here and here. So that's 4 pair. One of the ways I like to think about corresponding angles is, let's see, could you slide the angle along the transversal? Let's see. So here is our parallel lines. And then I'm going to look at this angle here. And then I'm just going to slide this angle along the transversal, move it along the transversal. And there's the other one that corresponds to it. So these two angles here, that one and that one, are said to be corresponding angles. Likewise, if I wanted to look at this red one and I wanted to find what corresponds with that, just slide it along the transversal. And there's another red angle that would be corresponding. Okay, 67, more just terminology than anything else. CPCTE is what we were doing in our book. Some books talk about corresponding parts of congruent triangles being congruent, but your book was pretty nice, and they talked about corresponding parts of congruent triangles being equal. So corresponding parts of congruent triangles are equal. That's what we want, CPCTC. Two lines not skew, not parallel. Okay, if they're not skew, they're in the same plane. And if they're not parallel, they have to be intersecting. So this is just a fancy question on what do you call lines that intersect? They are said to be concurrent. That's a nice word. You should look that up in the glossary. Concurrent lines are lines that share a point, so they have to be intersecting. Side angle side postulate. This is for proving two triangles congruent. So let's suppose we had two triangles and we wanted to prove them congruent. We would have to show a pair of sides and another pair of sides, and the angle in here in between those, that would have to be equal to that. What do you call that angle? It's called the included angle. Included angle. Lateral edges of a pyramid meet at the apex. That's more just terminology thing at the top of the pyramid. So think of a square-based pyramid if you want. The point all the way up the top is called the apex. Okay, so there's page 3. And let me stop this. That was only 8 minutes. So hopefully this will go a little bit more quickly. Thanks for staying with me.